This is mathheals.com. You can find more links to math YouTube videos here if you wish. And let's take a look at the complex plane, and hopefully I'm saying this right. De Moivre's theorem. 3 years of French in high school down the drain if I didn't say it right. First thing we'll talk about is a polar form. Now, we've seen in terms of the x's and y's before, like you have 3 plus 2i, for example. And then we have polar form that goes along with that. That's r times cosine theta plus I sine theta. Now, r is greater than or equal to 0, and theta is between 0 and 2 pi. Oftentimes it's written in degrees for ease. Now, these first problems revolve around what we kind of already know. Just to refresh your memory. Remember, we got x is equal to r cosine theta. Y is equal to r sine theta. We got cosine theta is equal to x over r. Sine theta is equal to y over r. Tangent theta is equal to y over x. R squared is equal to x squared plus y squared. And r is equal to square root of x squared plus y squared. Okay, so our first one, we got -1 minus I. And like I said, we've seen those before. What we haven't done is we haven't plotted it before. This says plot each complex number in a complex plane and write it in polar form. Express the argument in degrees. Well, let's plot it. Now, when we're plotting it, this is our real part here, and this is our imaginary. So our x-axis is our real, the y-axis is our imaginary. So we got -1 on our real, and then we got -1 on the I. So this would be that right there. Okay. Now we're wanting to put it into polar form. Polar form looks like this. R times cosine theta plus I sine theta. So we need two things. We need R and we need theta. Well, x is equal to -1 and y is equal to -1. So x is the real part here, and then y is the number that's before your I, which is in this case is the -1. Now first, we need to find r. And we got r is equal to square root of x squared plus y squared. So we got -1 squared plus -1 squared, which gives us 1 plus 1, which gives us square root of 2. Now the second item we're going to do is we're going to try to see if it's on a unicircle. Try to see if it is on unicircle. And how we do that is we got cosine theta is equal to x over r. Well, x we said was -1, and r is square root of 2. So if I multiply top and bottom by square root of 2, we get negative square root of 2 over 2. And sine is equal to y over r. Y was -1 over r, which is square root of 2. So that gives us negative square root of 2 over 2 when I multiply the top and bottom by square root of 2. Now if we look for this point on our unicircle, we would be looking for negative square root of 2 and negative square root of 2. Negative square root of 2 over 2 and negative square root of 2 over 2. Sorry. Well, this is on our unicircle. And they want us to express this in degrees, I guess. So theta, and where that's at, if I looked on my unicircle, would be right over to here. Pi over 4, 2 pi over 3, pi over 4, 4 pi over 4, 5 pi over 4, or 180 degrees plus 45, was that 225? I'm not very good with decimals. Let me actually look that up on the unicircle. Yep, 225 degrees. Now, if that doesn't work on unicircle, I'll go ahead and put it here. If 2 fails, then use tangent theta is equal to y over x. And we'll look at some problems dealing with that. But anyway, we found r, we found theta. Our polar form, which is what they're asking for in this problem, write it in polar form, is r times cosine theta plus I sine theta. R we said was square root of 2. Cosine theta, which is 225 degrees, plus I sine 225 degrees. And that's our answer. So cut our next problem. Got 5 square root of 3 minus 5i. And it says to plot each complex number in a complex plane. Now I could plug this in my calculator to get a little bit of better picture of what this is equal to. But this is like, that's 1 point something, say 6. So I go about 6 here, and then negative 5. Maybe somewhere right here. So let's say this is 5 square root of 3, and this is negative 5. So again, my real part, and then my imaginary part. And that'll give us our point. Now the idea on here with plotting it isn't that we're really concerned whether you can plot points or not. I'm not very good at that myself. Building a t-chart, I'll screw up one of the numbers. We're trying to see which quadrant we're in. That'll become important in some of the problems. Okay, so our first step is to find r. Well, remember x is the real part, so 5 square root of 3, and y is the number that's before our I. So y is equal to negative 5. So our formula, r is equal to square root of x squared plus y squared. So we got x squared, so we got 5 square root of 3 squared plus negative 5 squared. When we square this, we square the 5, which gives us 25, and we square the square root, which gives us 3, plus, and that squared gives us 25, which gives us 25 times 3 is 75, plus 25, which is 100, and square root of 100 is 10. Okay, see if it's on a unicircle. So cosine theta is equal to x over r, and sine theta is equal to y over r. Well, x was 5 square root of 3 over 10. 5 and 10 both divisible by 5, so that gives us square root of 3 over 2. Now y is negative 5 over r, which is 10, so that gives us negative 1/2. So I'm looking for the point, square root of 3 over 2, and negative 1/2. Which I think, well, it's 11 pi over 6, but 330 degrees. I'm not very good with degrees. But again, we just go around and we find a point that matches that. And so it's 330 degrees. Now our polar form is r times sine theta. Wait a minute. Try it again. Cosine theta. Plus I sine theta. So r we said was 10, and then we got cosine of 330 degrees plus I sine of 330 degrees. Now we don't simplify that at all. That's actually polar form. So that's the form we wanted in. And complex plane, so let me save this. Trig complex plane, Moivre Theorem, page 01, the PDF. There we go. Let's look at our next example. Here we got square root of 7 minus I. Okay, square root of 7, square root of 9 is 3, square root of 4 is 2, so it's somewhere between 2 and 3. So somewhere in here, and then that's negative 1. So somewhere right here. Don't really care precise here, we're just trying to see our quadrant. And we'll talk more about why that's important. Now x is our real part, which is square root of 7. Y is the number that's before your I, which is negative 1. So first thing we do is find r. So we got r is equal to square root of x squared plus y squared. X is square root of 7, so we got square root of 7 squared plus negative 1 squared. Square root and the second power cancel each other out, and we got 7 plus 1, which gives us square root of 8. And 8 is 2 times 2 times 2. Remember, we're looking for a pair of somethings. Here's a pair of 2s, so they're going to come out in front as a single 2, and we're left with 1 2 inside. Now, there's no square root of 7 on our unit circle. I could try it, but it fails. So then we go to step 3. We try to use tangent theta is equal to y over x. And so tangent theta, y is negative 1 over x, which is square root of 7. And I could try to simplify that if I want to, but there's no need, because we're immediately going to take inverse tangent or arctangent of both sides. So those cancel each other out, and we got theta is equal to inverse tangent, arctangent of negative 1 over square root of 7. Well, we want to plug this in our calculator. So I want to make sure I'm in the right mode. So I press mode, I'm going to down arrow, and then right arrow, and highlight degree, and press enter. We want to be in degrees. Now I'll do second mode to exit out. Okay. Now I'm going to do second tangent to get the inverse tangent. And then negative 1 divided by second x squared for the square root. And I'll put 7 in. And then press enter. And we get negative 20, I don't know, I'll take it 2 decimal places, I guess. 20.70.7 degrees. Okay. Reason why we plotted this first is we wanted to see what quadrant it is. And negative 20 degrees, that's in that quadrant, so that's correct. Remember, when you do an inverse tangent, the only 2 places it gives you is this quadrant and this quadrant. So if our angle is actually should be over here, then we have to do something special, like add or subtract 180 degrees, as case may be. Okay. I'm going to go back up to here, where I'm defining it. I said theta has to be between 0 and 2 pi, or 0 and 360 degrees if I think of it in degrees. This is not between 0 and 360 degrees. So what we want to do to it is we want to add 360. Because adding 360, we go all the way around a unit circle, we're back where we wanted to be. So Let's see. I already got this in my calculator, so let me just do a plus 360, enter, and take it 2 decimal places. 339.29, and then it rounds up, so 0.3, like that. Okay. So we found r and we found theta, and that makes sense when you think about theta. If I go all the way around, that looks like 339.3 degrees. So we got r cosine theta plus I sine theta. R we said was 2 square root of 2, and then we'll have cosine of 339.3 degrees plus I sine of 339.3 degrees. And that's our answer. Okay. Now these are given it to us in polar form, and it says write each complex number in rectangular form. So we're wanting to go the other direction. This one is a lot easier. Okay, so we got 5 cosine pi plus I sine pi. Well, what we do is we just look these up in our unit circle. Cosine pi, pi is clear over at the 180 degree mark, and cosine is our x part, which is -1. So here's pi, cosine is the -1, plus I times sine. Sine of pi is 0. Again, sine is our y right here. So then we got I times 0 is 0, so it drops away. 5 times -1 is -5. And that's our answer. Let's take a look at this one. We got 4 cosine of pi over 6 plus I sine pi over 6. Excuse me. Now, cosine of pi over 6 is equal to square root of 3 over 2 plus I sine of pi over 6 is 1/2. Pi over 6 is right here. Cosine is our x, so that's why that's square root of 3 over 2. Sine is our y, that's why that's 1/2. Now if I multiply this through, I got 4 square root of 3 over 2 plus 4/2 I, 4 times 1/2, which gives us 2 square root of 3 plus 2i. And that's our answer. Number 6. We got 7 cosine of 22 degrees plus I sine of 22 degrees. Well, 22 degrees isn't on our unit circle, so there's nothing special we can do here except for just plug it straight into our calculator and round it to however many decimal places. It doesn't really specify. I want to make sure I'm in degrees, so press mode. See, I'm still in degrees, so second mode to exit out. And again, we're just typing as we see it. So I got 7, beginning parentheses, cosine of 22 degrees, closing parentheses on 22, plus I. Now I is second decimal, and then sine of 22 degrees. You can put a closing parentheses on that, and closing parentheses on the beginning one here. Closing one on the very beginning one, and then press enter. Now we get decimals, which is okay because we know it's not on unit circles, so we're not going to come up with the exact answer. I'll take them 2 decimal places, so we got 6.49. Now to see what the second part is, you have to scroll to the right. See the 3 little dots here? So I'm going to use my right arrow key and scroll over. And it looks like 2.62. And if I keep scrolling, you see there's an I at the end. So there should be an I here. And that'd be your answer. Now let me save this. Typically, we try to use a unicircle if we can, because that gives us exact answers, and that's what we always want in trig if we can. Come up with an approximation like what we just did there. Sometimes we have to go with it, but most times we like exact. Okay. Let's say we're going to multiply and divide complex numbers. We got a special formula for that. And specifically, they have to be in polar form. So we can't have it in our normal form, our rectangular. So this says we got our first one. Z sub 1 is equal to R sub 1 times cosine theta sub 1 plus I sine theta sub 1. So again, we got our R and our theta. And then we got our second one, Z sub 2. And that's a different R and different theta. That's all that's saying. Then, if we multiply them, take Z sub 1 times Z sub 2, we multiply the R's, and we add the angles, as you see here. So you got cosine of the angles added plus I sine of the angles added. For division, we divide the R's, and then we subtract the angles. So it's very easy. Of course, the key is that it does have to be in polar form to use these formulas. So let's take a look at this first one. We got Z is equal to cosine 200 degrees plus I sine of 200 degrees. Now notice there's no R here, but if I were to put an R there, you always have the 1 if there is no other one. So it really is there, it's just implied. And then the other one is W. And W is equal to cosine of 120 degrees plus I sine of 120 degrees. And again, there's no R there, but there's implied 1. So that's 1 times cosine of 120 degrees plus I sine of 120 degrees. Now we want to do the multiplication division, leave your answers in polar form. Okay, so Z times W. Well, from our formula, we're going to multiply our R's. So we'll take 1 times 1. And then we'll add our angles. So we got 200 degrees plus 120 degrees. Plus I sine of 200 degrees plus 120 degrees. So 1 times 1, that just goes away. But then we got cosine 320 degrees plus I sine of 320 degrees. Now it wants us to leave it in polar form, and this is actually in polar form, so to go further would be to go against directions. Okay, now our division. We're going to divide our R's, so we take our 1 divided by 1, kind of boring. And then we'll take it and we'll subtract our angles. So we got 200 degrees minus 120 degrees plus I sine of 200 degrees minus 120 degrees. 1 divided by 1 goes 1, that goes away. So we got cosine 200 minus 120 is 80. So cosine 80 degrees plus I sine of 80 degrees. And those are our answers. Let's look at this one. Now degrees just work out so much better with these. Normally I don't like degrees, but they work out better with the formulas in this section. Here we got Z is equal to 8 cosine of pi over 4 plus I sine pi over 4. And W is equal to 4, and then cosine of 3 pi over 8 plus I sine of 3 pi over 8. And again, leave your answers in polar form after we get done. So we're going to take Z times W. We're going to multiply our R's, so we take 8 times 4. And then we'll add our angles. So we got pi over 4 plus 3 pi over 8 plus I sine of pi over 4 plus 3 pi over 8. Well, 8 times 4 is 32. And we have to get a common denominator to add these together, which would be 8. So I multiply the bottom part here by 2, so I have to multiply the top part by 2. So we've got 2 pi over 8 plus 3 pi over 8 plus I sine of 2 pi over 8 plus 3 pi over 8, which gives us 32. Cosine 2 pi over 8 plus 3 pi over 8 is 5 pi over 8 plus I sine of 5 pi over 8. And that's our answer. Well, let's look at division. Excuse me. Well, we're going to divide our r's. So we'll do 8 divided by 4. And then we'll subtract our angles. So we got cosine of pi over 4 minus 3 pi over 8 plus I sine of pi over 4 minus 3 pi over 8. So that gives us 2, and then I have to get a common denominator again, so which would be 8. So this becomes 2 pi over 8 minus 3 pi over 8 plus I sine of 2 pi over 8 minus 3 pi over 8. Which gives us 2 times cosine of negative pi over 8, 2 pi minus 3 pi, plus I sine of negative pi over 8. Okay. If I go up here, this says that polar form, the angle has to be between 0 and 2 pi. It can't be a negative pi over 8. So to get between 0 and 2 pi, very simple in this case, is we just need to add 2 pi. So I got 2, and then cosine of negative pi over 8 plus 2 pi plus I sine negative pi over 8 plus 2 pi. Now this is a mixed number, so I can work with it in that form. We'll take 2 pi times 8, that gives us 16 pi, plus a negative pi gives us 15 pi over 8. Plus I sine of 15 pi over 8. Again, I took the 2 pi times the 8, that gives us 16 pi, plus the negative pi gives us 15 pi, and then the 8 remains the same. And that'd be your answer. Let me go ahead and save that. And then let's look at our next problem. Wherever it might be. Okay, that one. Okay, let's look at this one. So we got z is equal to 3 minus 3i. And we got w is equal to negative square root of 3 plus I. Well, in order to use our formulas, again, these have to be in polar form. So we have to go through and put them in polar form. So first thing, of course, the x is the 3, y is the negative 3 here. First thing we have to do is find r. So r is equal to square root of x squared plus y squared. So r is equal to 3 squared plus negative 3 squared. And some of these you can actually just think it through and know what the angle is. R is not necessarily the case. 3 squared is 9. Negative 3 squared is 9. So that gives us the square root of 18, which is 3 times 3 times 2. So we'll bring a pair of 3's, comes out as a single 3. So we got r is equal to 3 square root of 2. And let me go ahead and do the r on this one too. Okay, so x is equal to negative square root of 3. Y is equal to the number before I, which is 1. R is equal to square root of x squared plus y squared. So r is equal to negative square root of 3 squared plus 1 squared. Square negative becomes positive, and the square root and the second power cancel each other out, and you're left with 3. And 1 squared is 1, which is square root of 4, which gives us 2. Okay, I think both of these are on the unicircle. So we got cosine theta is equal to x over r, and sine theta is equal to y over r. Well, x over r, we got 3 over 3 square root of 2. 3's cancel, and we got 1 over square root of 2, which is square root of 2 over 2. Sine is y, which is negative 3 over 3 square root of 2, which is negative 1 square root of 2, which is negative square root of 2 over 2. Cosine's positive, sine's negative. I don't know what it is. It's in the fourth quadrant. I'm just not very good with degrees. It's 360 minus 45. Was that 315? Let me go look. 315. Okay, for this one, again, I'm pretty sure it's on a unicircle. So we got cosine theta is equal to x over r. X is negative square root of 3 over 2. And sine is equal to y over r. Y was 1 over r, which is 2. So looking for the point, negative square root of 3 over 2 and 1/2. 5 pi over 6? What would that be? Okay. 150 degrees. I wish I was better at degrees. I can think radians, I just can't think degrees. Okay. So now we have our r and we have our theta. So this one, what am I dealing with? Z and w. So z here would equal to 3 square root of 2, and then cosine of 315 degrees plus I sine of 315 degrees. What's the other one? W. Okay, this is w. And we got r, which is 2, and then cosine of 150 degrees plus I sine of 150 degrees. Okay, and they want us to multiply them. So we'll take z times w. Remember, you multiply your r's together. So I got 3 square root of 2 times 2. And then cosine, and we add the angles. So we got 315 degrees plus 150 plus I sine of the same. So 315 degrees plus 150 degrees. Multiply these together. 3 times 2 is 6. So we got 6 square root of 2. Cosine, add these together. 315, 415, 465. Yeah, 465 degrees. Plus I sine 465 degrees. Well, the angle has to be between 0 and 2 pi or 0 and 360 degrees, not including 2 pi and 360. So here we're going to subtract 360 to get back to where it should be. So we got 6 square root of 2, and then cosine 465 degrees minus 360 degrees plus I sine 465 degrees minus 360 degrees, which gives us 6 square root of 2, cosine of 105. Yeah, 105 degrees plus I sine of 105 degrees. And that's our answer for the first part. Then we got to do division. So I'm going to divide my r's. So I'll take 3 square root of 2 divided by 2, and I'll subtract my angles. So I got cosine of 315 degrees minus 150 degrees plus I sine of 315 degrees minus 150 degrees. And then when I subtract those, it gives me 165 degrees plus I sine of 165 degrees. And that's assuming my eyes didn't get off when I was looking up these angles on the unicircle. Because again, I don't trust myself when it comes to degrees, but nothing else to get the idea. I could go off of a script such I know that everything would be perfect I'm putting on here, but part of the fun is just doing this from scratch. Keeps my mind a little bit sharper than it normally would be than if I was sitting there watching Family Guy all night long. Okay, and tablet just died. What am I doing looking for it? There we go. Now let's take a look at de Moivre's theorem. Now I know I screwed it up there. French teacher would be cursing if she knew how much I've forgotten. Okay, this is in polar form. R times cosine theta plus I sine theta. Then if you're taking it to a power, z to the n power, you take the r to that power, and then you multiply the angle times n. This is assuming n is greater than or equal to 1. Very simple, assuming it's in polar form. So let's take a look at first problem here. And if it's not in polar form, you have to do what we just did in that last example, which isn't hard. Okay, so we got 2 times cosine 105 degrees plus I sine of 105 degrees. And we're raising it to the 4th power. Now here we want to write it back in the standard form. So we don't want to leave it into our polar form. Well, if we're raising it to a power, you're going to take the r to that power. So we got 2 to the 4th. And we'll multiply the angle inside here by the power. So multiply it by 4. So we got 4 times 105 degrees plus I sine of 4 times 105 degrees. That gives us 16 cosine of 420 degrees plus I sine of 420 degrees. Well, I want to get this in the unicircle if I can, see if I can get an exact answer. So I'm going to take 420 degrees and subtract 360 plus I sine of 420 degrees minus 360 degrees. Well, 420 minus 360, was that 60 degrees? Plus I sine of 60 degrees. Okay, looking on our unicircle, cosine of 60 degrees, let me see, what is that? That's 1/2. Plus I, and sine of 60 degrees is square root of 3 over 2. Again, just looking those up in unicircle. Here's 60 degrees, cosine is 1/2, right there. And sine, which is our y, is square root of 3 over 2. Now multiply the 16 through, and we got 16 over 2 plus 16 square root of 3 over 2i, which gives us 8 plus 8 square root of 3i. And that's our answer. Let me grab a drink here. There we go. And let's look at our next problem. So we got, it's already in polar form. We got square root of 2 cosine of 3 pi over 20 plus I sine of 3 pi over 20 raised to the 10th power. Now again, that French-sounding name, de Moivre's theorem, we're going to take the r to the 10th power, so we got square root of 2 to the 10th power, and then we'll multiply 10 times our angle. So we got cosine of 10 times 3 pi over 20 plus I sine of 10 times 3 pi over 20. Okay, this is, if I think of the square root of 2, square root of 2 squared, for example, that would give us 2. Well, here we have 5 of those, because, so we're going to have 2 to the 5th, which is 32. If you were to actually write them all out, square root of 2 to the 10th, you'd see this is what you get. And then we got cosine, multiply these together, we got 30 pi over 20 plus I sine 30 pi over 20. Which simplifies. They're both divisible by 10, so that gives us 3 pi over 2 plus I sine of 3 pi over 2. 3 pi over 2 cosine is our x, which becomes 0, plus I sine of 3 pi over 2 is negative 1. 0 drops away. Negative 1 times I is negative I times 32 gives us negative 32i. And again, 3 pi over 2 is right down here. That's where I was getting the cosine is 0 and sine is negative 1. And those will be your answers. So let me save this. I think these last problems are kind of neat, actually. Formula makes it look kind of complex, but it's just a very cool idea what you can do with these. Not that I can type it right up here, but let me try that again. That should be a close parentheses there. Oops. There we go. So okay, we got it in polar form, and then let n is greater than or equal to be an integer. There are indistinct complex nth roots given by this formula. We'll come back to this formula. So for example, we're finding the complex fourth roots of 4 minus 4i. Like, okay, what in the world are you saying there? This is type of problem you're set up with. You're trying to solve this. X to the fifth is equal to negative 27. From college algebra, we know the fifth power means we have 5 answers. But typically we only know like one way, or we only know a way of getting maybe one answer. Well, where's the other 4 answers? That's what we're going to be looking at. And so we're going to start here with this one, and we'll see. Then we'll take a look at the formula and see how in the world this works. Now, to say we want the complex fourth roots of 4 minus 4i, that means like originally the problem started this way. We had like x to the fourth is equal to 4 minus 4i. And we solve for x, so we take the fourth root of both sides, like this. And we'd end up with x is equal to the fourth root of 4 minus 4i. So this is what that's saying. Find all the complex roots, the complex fourth roots of 4 minus 4i. So complex fourth roots, that means you have 4 in your index here. Okay, well for this formula to work, we have to have it in polar form. So that's our first step. So let's take a look at 4 minus 4i. Well, x is equal to 4, y is equal to negative 4. And then r is equal to the square root of x squared plus y squared. So r is equal to 4 squared plus negative 4 squared, which is 16 plus 16, which is square root of 32, which is 4 times 4 times 2. So we get r is equal to 4 square root of 2. Okay. Now, I think it's on a unit circle, so we can use that to find theta real easy. Cosine is equal to x over r, and sine theta is equal to y over r. Well, x is 4, and r is 4 square root of 2, so that gives us 1 over square root of 2, which is square root of 2 over 2. And sine, we have negative 4 over 4 square root of 2, which gives us negative 1 over square root of 2, which gives us negative square root of 2 over 2. I'm not quite sure why I picked so many down there in that quadrant. But what is this? 360 degrees minus 15, what is that? Or not minus 15, but it's this one here, 315 degrees. Okay, so our polar form, so what we're working with is r times cosine theta plus I sine theta. R is 4 square root of 2. And then we got cosine of 315 degrees plus I sine of 350 degrees. So that's what we're finding. So we're finding the, what are we finding? The complex fourth roots of that. So complex fourth roots of 4 square root of 2 cosine of 315 degrees plus I sine of 315 degrees. So again, it has to be in polar form like that. And our formula, pretty complex looking, but really just plug in your different values. But I'm going to show you kind of a shortcut way to do this. So first thing we do is find the nth root of r. That's this right here. So we got the nth root of r. Now n is how many we're talking about, so we're talking about 4. And then I put 4 square root of 2 in here. So nothing exciting, you just put r in there. I could simplify that a little bit, I think. I'm trying to think if it's worthwhile simplifying, to be honest. I mean, you put this back inside and you get 32. Let me mention it. This is like the fourth root of the square root of 32, which would give us the eighth root of 32. Not sure if this is better or this is better. I may go with this. Remember your property, if you got a radical inside of a radical, you can multiply the indexes together. 4 times 2 gives you 8. So we go with that. 2. Find our initial angle. Now our initial angle, if we were to go with the formula and plug 0 in for k, this is 0. 2 times 0 times pi is 0. 0 divided by anything is 0, so that would drop away. So we just got our theta divided by n. So our initial angle, and I don't know, I'll call that, I don't know, IA, I guess, would be theta, which was 315 degrees here, divided by, and again, we're dividing by n, so we're dividing by 4. And where's my calculator? Okay. 315 divided by 4. So we get 78.5 68.75 degrees. Now we'll find our add factor. And I'll call that AF. Our add factor, we take 360 degrees, it's always 360, divide by our n. So we take 360 divided by 4, and that gives us 90 degrees. Now we're going to use these to write down our answers. Now the fourth roots means we're going to have 4 answers. So first answer. We're going to have our nth root of r times cosine of our initial angle plus I sine of our initial angle, which gives us the 8th root of 32, cosine of 78.75 plus I sine of 78.75. So that's our first answer. We're going to have 4 answers. So what we do is the add factor we found here, we're going to keep adding it. So I'll take that and I'm going to add 90 degrees to both of these. So our second answer will be the 8th root of 32. And then I got cosine of 78.75 plus 90, 168.75, plus I sine of 168.75. I'm assuming they want us to leave it in polar form, but let me check. Leave your answers in polar form. Okay. Then we'll keep adding 90. That's our add factor. So the next one is the 8th root of 32 cosine plus 90, 258.75 plus I sine of 258.75. And we're just about there. We got one more answer. So we'll add another 90 degrees. So plus 90, 348. So we got the 8th root, 32, cosine, 348.75 degrees, plus I sine of 348.75 degrees. Now those would be our 4 answers to this initial problem up here, where we got x to the 4th is equal to 4 minus 4i. Kind of cool. Let me save that. And then we'll look at our last problem. There we go. So number 13, we have x to the 5th is equal to negative 27. And I'll take the 5th root of both sides. So we'll have the 5th root of negative 27. Well, I need to put that into polar form. So we got negative 27. If I think of that where that's at, negative 27, that's over here, angle-wise, and I could go through all those steps and everything, but angle-wise, this would be theta is equal to, and I want to put this in degrees, so let me think it through. That's, oh, I hate degrees. It's pi. What is that, 180 degrees? And r would be 27, because we're going out in this direction. Now, if I went through all my different formulas, I'd find out that's true. Okay, so we're really finding the 5th roots of 27 cosine of 180 degrees plus I sine of 180 degrees. Okay, now we need to find the nth root of r. So that'd be the fifth root of r, which is 27, which we can't break down any because 27 is 3 times 3 times 3. Now our initial angle, that's going to be our theta, which is 180 degrees, divided by 5, because that's our n. And actually, let me write down the formula. So we're going to have theta, that's our initial angle, divided by n. So we've got 180 degrees divided by 5. Which gives us 36 degrees. So 36 degrees. Now our add factor is going to be 360 divided by n. So we'll have 360 divided by 5, which gives me 72 degrees. Okay, so our answers. Our first answer, we'll have the nth root, so we'll have the fifth root of 27, and then cosine of our initial angle, which is 36 degrees, plus I sine of 36 degrees. That's our first answer. Now we're finding the fifth root, so we're finding a total of 5 answers. So I'm going to keep adding my add factor over and over. So I'll add 72 degrees here. So this will be the fifth root, 27, times cosine. That's 108. Probably shouldn't try to do that in my head this late at night, but maybe I feel brave. Yeah. So that's our second answer. And again, we'll keep adding 72 degrees over and over. So this will be the fifth root of 27, cosine of 180 degrees, plus I sine of 180 degrees. And this one, you could plug these in, and actually some of them would work out really nice, because 180 degrees is on our unit circle. And then we'll add 72 again. Formula looks intimidating, but if you use the little shortcuts I'm giving you here, they're really not too bad. I don't know what this is, so let me plug in my calculator. 180 plus 72, 252. Plus I sine of 252. That's our fourth answer. And then we'll add 72 degrees again. And we'll have our last answer. So fifth root of 27 plus 72, 324. So we got cosine of 324 degrees plus I sine of 324 degrees. And those will be our 5 answers. And the end of that section. So let me save this. Stop the recorders.